Here is the text with proper punctuation and formatting. Ray specialists have tracked down that using our new 10 billion toy, the flight plan could take an especially expansive turn before it will turn out to be a reality. On the off chance that it goes according to plan, the visit to Proxima may take around different years. So, all things considered, it will probably be several years before we can ascertain if there is indeed life on that planet. The question remains, would it be wise for us to convey that we are all alone in this universe? The Webb Space Telescope has found a few non-human-like things some distance from Earth, guiding us toward a strategic response. Our search for existence beyond us has been a topsy-turvy journey for the entirety of human development, to such an extent that we have suspended a truly tremendous number of media works and theories. This is to account for our wonder with regard to our location and separation in the universe. It has been standard for humans to tirelessly look for a mate, not considering how alien-like they may be. We should ponder more, and yet the responses we seek may not be the ones we truly desire. Could they be the disturbing truths that come closer to us as we evaluate the sharp discoveries in the states of universes and planets in the quest to find something we may not be prepared to see? Lighting very far away, researchers have sorted out what might be the best significant openness of all time. In 2021, right when the James Webb Space Telescope was put into plan, a completely entrancing speculative question was raised around the limits of our advancement. The question was whether, at some time, our telescopes could see artificial light on another planet close by Proxima B. Proxima B, the nearest exoplanet to Earth, is in the habitable zone of our nearest neighbor, the small but notable star Proxima Centauri, about 4.24 light-years away. Since the exoplanet is not many models away from its star than Earth is from the Sun, Proxima B should be tidally locked, with an unending dayside and nightside, much like our Moon. Theoretically, high-level human development on Proxima B could transfer warmth and energy from the dayside to the nightside using photovoltaic cells that produce power from starlight. In a paper with Manusvi Lingam as one of the specialists, it was shown that using the dayside through solar chargers might be feasible with future telescopes. Given that the JWST was further advanced, it allowed us to extend our search for such devices to intriguing exoplanets like Proxima B. In the long term, the James Webb Space Telescope, which launched in 2024, did exactly that. Using its higher sensitivity and broader set of objectives, the JWST could have detected the light signatures we were looking for, potentially flinging us into another giant era of human advancement. This would allow us to explore the universe of planets and exoplanets to understand how this was even possible. James Webb's giant objective is to analyze Proxima and its secrets. Throughout time, people have considered the nature of the universe. What are we? Where did we come from? Where are we going? ***, these are common yet very hard questions man has endeavored to answer since he gained consciousness. However, in the age of empowering technology, one might wonder if we're any closer to answering these questions. If you ask a practical person, they might say we're still at stage 0 of understanding ourselves in the universe. However, ask an astrophysicist, and watch him weave around in excitement as he rushes to tell you about the most mind-blowing discoveries humans have made about the universe using their advanced technological tools. These gadgets, though not given extraordinary interest by the general public, are clearly a testament to human advancement. We now have the tools to explore, and it's time we push forward and explore the universe. Naturally, experts and astronomers have done that. Through technology, we tackle the coming of that express development, which is now responsible for the new discovery of what could be lights on another planet light-years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the product of human missions into space, aiming to address several important questions. Are we alone? Where did we begin? Where might we go next? ***, clearly, this infrared space astronomy tool has already begun answering these questions, though with a few caveats. First, you might find yourself asking, what even is Proxima B? Proxima B, sometimes known as Alpha Centauri B, orbits an M-type star. Earth-like planets are a class of planets that are potentially more massive than Earth but lighter than gas giants like Neptune and Uranus. They can be made of gas, rock, or a combination of both, and their sizes can range from twice the size of Earth to several times its mass. Regarding Proxima B, Its mass is believed to be comparable to 1.07 Earths. It takes about 11.2 days to complete one orbit of its star, compared to our 365.25 days. You could genuinely examine the characteristics of the giant star Proxima B orbits, especially under the scrutiny of the entire electromagnetic spectrum. The star has an overall luminosity of only around 0.16% that of the Sun, and within its vast reach, its brightness appears generally dimmer, as it emits only 0.056% of the Sun's brightness. The star radiates a significantly lesser amount of light energy than the Sun. More than 85% of its emitted energy is in the form of infrared radiation, and Proxima B's transparency was discovered way back in 2016. You might be curious as to why Proxima B, among a multitude of stars, planets, and celestial bodies, is the focus of such intense interest. There are several reasons why astronomers are particularly focused on Proxima B. First and foremost, it is the nearest star to our solar system and, by definition, to us. Despite the fact that 4.24 light-years is a vast distance to us Earthlings, in the grand scheme of the universe, it is a relatively small distance. Thus, Proxima B, our nearest neighboring star, is placed high on the priority list. Moreover, Proxima B's low luminosity means that it is one of the most visible star systems in the night sky, just behind Sirius and Canopus. However, the most interesting aspect of Proxima Centauri and Proxima B is that it might be habitable, as it falls within the habitable zone. The potential for life is high, which is why astronomers have taken on the challenge of exploring the depths and distant reaches of the stars. This is where the James Webb Space Telescope comes in. Given that the JWST continues its examination of the exoplanet, we edge closer to the outcome of these missions, from searching for extraterrestrial life to exoplanet evaluation. So what exactly is SETI? Considering that people are, after all, a curious species, it's no surprise that an undertaking like SETI, Search for Extraterrestrial Intelligence, emerged with such an extraordinary vision. God has created an ideal journey, but instead of gold, we are tasked with searching for signals, specifically electromagnetic signals, from civilizations beyond anything we might ever consider. SETI aims to search for extraterrestrial data, and it is our mission to capture signals and results of intelligent life hiding amidst the stars. Our mission dates back to the 1900s, shortly after the radio age arrived in human use. People like Nikola Tesla and Guglielmo Marconi emerged with extraordinary ideas. They hoped to use their clever devices to make interstellar communication possible. Tesla even considered the possibility of communicating with Martians using his radio transmission device. Fast forward to the 1960s, and we find ourselves in the midst of Project Ozma, the brainchild of the late great astronomer Frank Drake. Armed with a powerful radio telescope, Drake scanned the distant cosmos for signals and signs of intelligent life. Unfortunately, his efforts did not yield results, but the mission set a precedent. Researchers worldwide began tuning their antennas to the infinite symphony of space. Meanwhile, in the Soviet Union, our counterparts behind the Iron Curtain were equally excited about the search for extraterrestrial communication. Soviet scientists turned their attention to the stars, looking for those elusive signals. Thus, the stage was set for a never-ending quest. But what was this high-quality signal captured amidst the vast noise, causing a wave of excitement and curiosity? The wow! Signal *** transported waves of wonder through established researchers. As the years went by, the search for intelligent signals only intensified. From T2 to the M-Hug Cyclops, researchers went all out in their quest to solve the ultimate mystery. Then, in a fortunate or perhaps fateful turn of events, a coded radio transmission from Mars through telescopes reignited the flames of exploration. But what does that signal look like now, and how has humanity progressed in its missions to detect artificial lights on Proxima B? In a 2021 research paper titled Detectability of Artificial Lights from Proxima B, researchers Avi Loeb and Abraham Loeb presented a project to investigate the feasibility of detecting artificial lights emanating from the dark side of Proxima B. Given that Proxima B is located in the habitable zone of its star, the study aimed to determine whether Proxima B could potentially support life and how we might find out. Given Proxima B's significance as a target in the search for extraterrestrial life, the researchers added an intriguing yet surprising detail: the discovery of a speculative radio transmission from Proxima B. Well, The signals detected were not from Proxima B itself. They carried enough mystery to reignite excitement in the scientific community. So, what happens next? Where do we go from here? The answer lies in the hands of human beings as we advance our technology and, with some luck, continue exploring the universe in search of answers. The question is no longer, are we alone? But rather, how close are we to meeting our cosmic neighbors?